Okay, grade 11s. I have an example here that I took from the Theory and Workbook Physical Sciences grade 11 compiled by A. Olivier. And it has to do with making use of bond energies to show that the combustion of methane in oxygen to form carbon dioxide is exothermic. So the question is, prove that it is exothermic or not, or the question can also be determine whether something is, what the sign of delta H will be. So the combustion of the methane is given by this formula, CH4 plus O2, and you will see also in organic chemistry that it's always CO2 and water as your products. Now, for you to be able to work this out and then work with the bond energies from a table, then the table of values will look something like this. Now, we have here different bonds in terms of, we've got the CC single bond, we've got CO double bond, we've got an O double bond. Sometimes they can put an O single bond in the table, and you need to know, the point is that you need to know what types of bonds you're going to get in these molecules. So therefore you need to take your knowledge from molecule shapes and types of bonds in molecules to actually determine. So the next step would be to write all these substances in structural form to actually know what kind of bonds and how many bonds of each you have. So the CH4, your methane, your tetrahedral molecule, remember, is looking like that. Your oxygen, remember that it is a double bond oxygen. It comes from your covalent bonding knowledge from grade 10, as well as your CO2, and then the water molecules. So it's also balanced, so that's why there's two of them. Then you need to remember the formula that I used before is for delta H equals the energy in minus energy out. Right? So for this molecule, you then see that there's actually 4 mole of CH bonds, or there's 4 CH bonds in, and the oxygen, and remember we're working now with your reactants. So there's 2 mole of O double bond oxygen bonds. There's 2 of them. So you will simply get the values from the table. All right, so you will go to the CH, it's 413, so there's 4 of them plus 2 oxygen double bonds, the 498. Okay, and then you would calculate the other side's energy, the energy out. So that's the formation of the products. So there's 2 C double bond O, and it will be the 745 plus the 4 OH bonds. There's 4 of them, 463. The OH bonds, that one. So you will add it all up and then get the total, and then you see your heat of your reaction, or delta H, is your energy taken up and energy released, or your energy in minus energy out, and that then gives you a negative value of minus 964 kilojoules, and the negative delta H value indicates that the reaction is exothermic. So that is just an example of how they can actually ask it by giving you the table of bond values, bond energies. Now remember what bond energy is. It is the amount of energy taken up or amount of energy released when bonds are formed or broken. Right. Thank you.